let's talk about how we can show that the limit does not exist for two variable functions. We first take a look at the situation for a single variable case. We have limit x approaches 0, absolute value of x divided by x does not exist. That's because when we approach from the right side and the left side, we get two different values, which means that the left limit does not agree with the right limit. And that is how we show that this does not exist. In other words, in order for a limit to exist, that we should always have the same value regardless of the way it approaches. Okay? So we're gonna use this idea to show that this limit does not exist. Okay, so what is this limit? This is when the point x and y approaches 0, 0 of this kind of function. Okay, so we just say that if the limit exists, then we should always have the same value regardless of the way it approaches. So it should not matter for what kind of path we choose for this point to approach. And in other words, if we want to show that the limit does not exist for this function, then we will need to find two different paths where this point approaches 0, 0. And then we need to obtain two different values for these two different individual paths to show that the limit does not exist, which is going to be the exact same idea in here. So because we are having that this point approaches 0, 0, we see that there are many different ways that this point could approach 0, 0. For example, I can approach 0, 0 along this straight line, which is y equal to, let's say, 2x. Okay? I'm gonna get a point from here and then drive this point along this curve to go to the origin at this way, on this path. Or I can choose to go to the origin along another path, which is, let's say, y equal to 1 over 2x. Okay? So that's kind of like two different ways to approach the origin 0, 0. If I could obtain two different values as the point approaches 0, 0 on these two different paths, then I can conclude, just similar to what this example in single variable calculus case, I can conclude that the limit does not exist. Okay, so let's do it. We're gonna first do it along the path y equal to 2x. Okay, along this path we're gonna have this value is gonna become, what does it become? It's gonna have limit, right? Because we are going along this path, so we can replace the y with 2x. So this is gonna become x plus 2x by replacing y with 2x divided by x minus 2x. Okay? And because the expression that we have here is only in terms of x, okay? So we can just see what that x point goes. As this point approaches 0, 0, we see that the x value is approaching 0. Okay, so that is equivalent to just saying x approaches 0, which is a limit of a single variable calculus function. So we can easily calculate this. This is a limit x approaches 0, 3x divided by negative x, which is obviously negative 3. Okay, so now we have the value of the function as the point approaches along this path equal to this value. And then we can try to see what happens for this path. So secondly, we're gonna do along y equal to 1 over 2x. Okay, and then we're gonna have similar things by computation. So this right now is becoming this value becomes limit, we're going to replace y with 1 over 2x, okay? Replacing that as x plus 1 over 2x, and then x minus 1 over 2x. And because this is an expression in terms of only x, so we should only care about what the x value is approaching. X value is approaching 0 as the point approaches the origin. And then we calculate this sort of expression. X as approaches 0, we have 3 over 2x divided by 1 over 2x. Okay, and easily calculate that, which is going to be 3. Is that 3? I think so. This is 3. Okay, and now we see that these two values that we have just calculated are different. Okay, different value. Which tells us something like this. We obtain two different values by choosing two different paths. So that now that we can conclude that because the value is different on different paths, so the limit of this overall function does not exist.